Hello everyone, so today I'm going to be sharing a video on debugging, and I will be sharing everything I know on debugging, the tips, the tricks, everything that I've learned throughout my experience I will share in this video. So let me begin. First and foremost, what is debugging? Debugging is the process of identifying and removing errors from computer, hardware or software in terms of software debugging. So I basically just borrowed it from Google right off the bat, but the context here is that I'm going to mention debugging in terms of finding and solving bugs. So the first thing we need to realize that the most important part actually is that there is not a single program that doesn't have bugs. Every single program has bugs, and if there is no bugs, that means that either nobody is using it, or it's super simple, so simple that everything will fit in a single sheet of paper, which is to be honest, inexistent almost. So having bugs is part of the software development life cycle and maintenance as well, especially over the years. So let me just take a sip. So here I'm going to share all the tips and tricks that I can, the experience itself that I can remember. And one thing we need to realize is that debugging is closely tied down to problem solving. They're very related. When we talk debugging, we also talk about problem solving. And if you want to become good in debugging, you need to be good in problem solving. So it's actually quite similar to detective work. You need to know how to find leads, and from that part you try to reproduce the errors, and then you wait, let me just get down with the theory. So problem solving, here I'm just going to be listing down the problem solving techniques, and from that we are going to see how we can use it for our debugging session. So let's begin. We have a lot actually for problem solving. Top-down approach, bottom-up approach. I'm just going to list them down and describe each one in terms of concept and how they apply to debugging. We have convergence, divergence, not the movies. There are actually movies, well-known movies on that. And then we have reverse engineering. Let's see, what do we have again? In terms of problem solving, we have, for example, let me just start with this one already, and then we will see how we can, there are so many other things to mention as well. So let's first talk about the requirements, which is as important whenever you're working on a project. It's very, very important to know the stack well. I was going to write full stack, but in any project that you're working, it's important, clearly important to know your stack well. Know different layers. This is extremely important because sometimes that's the difference between solving a bug within 2 hours and solving a bug that takes weeks actually. So you need to, I will give, of course, for all of that, I will give some example. So it's very important to know there's your stack, use MVC, how the data travel throughout the application. This is very important. And for web application, for example, web app, you have the server, you might have some middleware, and have the phone. And for example, it might be like that, it might not be like that as well, but for the most part this is how it is. So right now I'm going to show you. So these are the requirements. So let me first take an example in, let's say you are using a typical stack, an open source stack that people use a lot is, for example, React plus GraphQL plus a backend. So let's say for me, for example, I use Rails, but you can also have Node.js, you can also have Laravel and similar technologies. So it's very important to know your stack, especially how data transfer from one pod to other. You don't need to master every single pod. So this is actually a myth. I've rarely seen, or in fact, it's not even recommended that you master React, you master GraphQL, you master everything, because nowadays computer software or not is not the development process itself. It's not so easy. You have CI/CD, so it's very hard to master everything. The most important part is to know how data is transferred from one pod to another, and of course know how to debug it. Of course, I will arrive to it in a few moments. So know the layers that are used, and for example here MVC, model view controller. So the model view example is just a way to represent data on the screen, and you have the model for the logic, to have the view, which is the UI, and the controller to simply take in the request, do some validation, and maybe not even that, just take the request and render the view, for example. So it's very important that you know your software, your stack well. So once you've done that, let's move on. Let's take a problem, a sample problem right now, and from that it's going to be easier to apply these different problem solving techniques. There are more. I didn't put everything in it. Let's put it though. Let's just add a few of them more. Maybe we have the circus analysis. So yeah, problem solving, and it's also debugging as well. It's not only problem solving alone, so we are talking about both. Already the context here is about debugging, and I didn't even start with this one. This one is called brute force. Okay, let's begin with first and foremost the scenario. Now it's only this one is moving. Alright, let's begin with this. We need a scenario. Here, let's start talk. So let's say we have a bug. We have a bug in a React application. Yeah. And for example, here we have a user cannot cannot see all the products, only some. Okay, so how we'll do that? So let's assume we are using a React GraphQL Rails stack, but in reality you can use any of the modern web application frameworks like ASP.NET, Angular, Vue.js, and many others. So reality is I'm just using as a scenario, but these apply for everything, each of these technologies. So okay, let's continue. Once I've done that, let me take an example. So let's continue with this example, and okay, I'm just figuring out how to use this. So okay, yeah. So brute force, what you are going to do is, it's like solving algorithm. Yeah, brute force, you're not sure where to start. You just open your editor, your code editor, your IDEs, and let me also put IDEs that you can use, editors, because they're very important. I'll say in a moment why. VS Code, say JetBrains IDE, JetBrains, example, line. Okay. So you go on your IDE, you open every single file, and then from there you try to figure out. It's just like the brute force algorithm where you try to break an encryption. You figure out, you it's the least effective way. But if you don't know, the pro here is that if you don't know the project well, you're a starter, and you don't also know the problem domain well, it can be a good idea. It will of course take a lot of time, but sometimes, especially at first of a project, you have a lot of time, so you can use this. Otherwise, this is for the brute force. How about a top-down approach? For the top-down, you start here. Let me draw it. You have your boxes. Yeah. So how it works is a bit similar, but let's say we are debugging every application. So we start with app. Here we have services, for example. We have components. So we are actually debugging the same product. And here we have helpers. Let's say something like that. Okay, so what are we going to be doing right now is simply start with the app, the different file structure, and go down, drill down into maybe services. We'll read them, but it's not like brute force. You just don't open everything. So you don't see products, so maybe you go on the components products. You try to locate the component with product, and from that maybe you are using context API. You try to debug from the top. You go down and down, because normally what happens in a React application is you have a lot of different components. You have the parent component, you have your child component, and it goes down like that. So you start at the top and you drill down. So that's the top-down approach. It's actually a good approach. If you similarly, you know it's not like the brute force in a sense that you don't know anything. You know your project a little bit. And you also know what is here. Normally, if we are talking about products, of course, in computer terminology, in software development, naming things are hard, and the advantage though is that here we know that there's products, and most probably we'll have components named products, we have services named products, so we have somewhere to start, and we can just drill down. Now bottom up is different. Bottom up, the approach is the reverse as expected. So instead of starting at the top, what you do is, so let's take an example. Here is your web app, and we are going to be using React Dev Tools. So let's here, so just an example. You know that here you have different pieces. So we should be seeing list of products here for the user, but it's not happening for whatever reason. There is a bug, and here's navbar, for example. This is my beautiful web application. We do not see this. The list of products is not appearing. So the starting point for that is you use your React developer tools, and then you inspect. So a developer tools is if you've not used it before, it's similar to the Chrome developer tools, a little bit similar, not totally. So you can inspect element, and also you can see the state. So when you're going to inspect element here, so you can inspect element, and let's say we have the product component directly from that, or something like product item component. So when you inspect the element, you see that this is missing. So you go, the missing products are from the product element, and therefore from that you can open directly with your editor, VS Code or any other editor. I will come back to that a bit later. And yeah, from that you can look for the error. Okay, so before I continue, there is something quite important to mention. And in fact, it's pretty pointless if you can't do that. Let me go back to that. It's ability to reproduce a bug. That's very important. So let's say the same bug local machine, on my local machine, I cannot reproduce the bug. So this makes it extremely hard. This actually makes it extremely hard for me to locate, to isolate the problem and fix it. It's like, I always say this to my colleagues, if you can't reproduce a bug on your local machine, it's like shooting a moving target in the dark. Not only you don't see the target, but when you shoot, it's moving. So the probability that you actually fix the bug is almost nil. And sometimes add to that, the feedback you get from deploying can take a lot of time, and which even reduces your chances. So let's continue with that. This is an important requirement, and there are some strategies I will share with you, of course, because in this video I'm going to share everything. So maybe later I will share more about how to strategies about, let me just put it in the slide. Well, I'm not really using slide right now. Well, we had strategies for reproducing bugs. So I'll come back a bit later to that. Some very important one as well. Okay, now in terms of convergence and divergence, these are key problem solving techniques, and they are used a lot to generate ideas in creative work. So convergence is where you start with multiple points and then finally you converge to a single one. So it's a bit like I've already mentioned. Still, we continue with our example for the list of products that are the list is not appearing, and this is only for a particular user, so we come back to that later. And the important part is with convergence, you know, you have several starting points. So like I said, you have, for example, product components, product services, product store. And so you from that you try to figure out a single point where the error is actually occurring. So it might be, for example, you need to try different, this is where your editor debugging, especially use of breakpoints, come into action, but you can also use console logs or puts, but they are not really recommended. If I have time, I will also explain this. So like I'm explaining, I already saying, is that for example, you try to see if your data, you're getting the data from the backend. If not the case, why the data is not appearing, and if the data is appearing, is there an issue with the format? Why it appears for other users but for this user it does not appear? So you use convergence to finally reach one point, because normally you might have a problem with a point and you have the bug at one point, and then you solve it and everything continues to work. That's convergence. Now divergence. Divergence is different, and normally from my experience it happens when you have a different set of problems. So wait, let me try to, so divergence is different. You have there was actually a movie, a triad of movie a few years back. So you diverge, it's a bit like this. Here, so you diverge. So in terms, this is actually a very interesting approach to problem solving, to creating ideas. For example, let's say you want to write a book and you want to market it well. How you do that? You use divergence. For example, you create the book, you create snippets that you post on social media often, you create a video and so on and so forth. So, but how does it apply to Let me just jot this down. So now the question is, how do you apply it to problem solving? The thing that you know is you have starting point. So let's put it as an abstract idea, the product itself, because the user can't see the products. So then you try, is it the services, is this the data, is it the UI, the data, is it the database? You need to ensure that yes, I'm actually, the UI works, or the data is appearing, we are getting the data, or you go into the backend and you try to see if everything is correct. So maybe there's an issue with the data itself, but let's assume that other users have it's working for them, so why is it not working for you? So this helps you when you use the divergence technique to problem solving and especially debugging. It's actually very similar to brainstorming, and brainstorming is just a process of listing down different possibilities, different scenarios, and it's quite similar, but with divergence you just diverge. In fact, divergence is very similar to, if I can put it, it's super similar to mind mapping in this way. Okay, so let's continue. Reverse engineering. So reverse engineering here, I don't think it's super applicable in every sense of debugging, but I'll just share a quick story with you regarding reverse engineering. I remember a lot of time ago we bought games for cheap, and they were hacked actually, and when you install the game you click on an exe and it did some stuff, and you could play the game without buying it. And what it did is actually, wait, I'm just going to continue the video a bit later.